What is going on, everybody? It is Kistner again, and today we are looking at section 2.6, the quadratic formula. Now, this is a very important section. The quadratic formula will solve any quadratic equation. Any quadratic equation, whether it has real solutions, imaginary solutions, no solutions, whatever, it will have a solution from the quadratic formula. You will need to memorize it. I will give that to you. I'll show you that, and you will need to memorize it. I'm not going to say I don't think you're going to have to. You do need to memorize it. It will look kind of daunting at first, but I promise you it is very easy to memorize once you use it, as much as we're going to be using it. So let's get right into it. So turn to page 54 in your student companion, and let's look at this. Example 1 simply says solve using the quadratic formula. Well, it'd be good to know what that is. The quadratic formula is x equals negative b plus or minus the square root, and it'll be a big long square root here. It'll be b squared minus 4ac, and that is all the top of a fraction. That's all over 2a. So pause the video if you have to. Make sure you have that written down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it is very important that you understand that all of that is under the square root symbol, and 4ac is a number that you will multiply by itself before you subtract. Now, where does this b, a, and c come from? Well, it's straight from the standard form of the equation. A, b, and c straight out of the standard form of the equation. So let's do that for example 1 here. A is 2, B is positive 6, and C is positive 3. So if I plug this in, now another key I should have mentioned is you have to be equal to 0. The quadratic formula, you have to start in standard form equal to 0. So if I plug this in, it'll be x equals. That's what we're solving for. It solves for the x. This is like where it crosses the x-axis. This is your solution. These are your x-intercepts. X equals negative b, so it's negative 6 in this case. It's negative of b, plus or minus the square root of b squared, so of 6 squared, minus 4 times a times c, all over 2a. 2 in this case times 2. Now we could type this into our calculator and get a number, but what I would suggest doing is breaking it down step by step, because we don't want a decimal. Your calculator will give you a decimal, and a decimal is not your best answer here. So x is going to equal negative 6 plus or minus. This plus or minus is going to give us our two answers. The square root of, and 6 squared is 36, minus 4 times 2 is 8, times 3 is 24, so it's 36 minus 24, all over 2 times 2 is 4. So let's start simplifying this now. X equals negative 6 plus or minus the square root of 12, all over 4. Now that is an answer for us. This is what we're going to leave the answer as, but this square root of 12 will simplify. The square root of 12, if you remember, can be broken down as the square root of 4 times the square root of 3. And the square root of 4 is 2. So really, this is negative 6 plus or minus 2 square roots of 3 all over 4. Now on this one, I can factor out a 2, and I'm left with negative 3 plus or minus the square root of 3. And on the bottom, I can factor out a 2. This is 2 times 2. So really my final answer will be, this 2 will cancel down here and leave a 2. My final answer will be negative 3 plus or minus the square root of 3 over 2. This is x. Now that is a really weird decimal, and I'm going to type this into my calculator here. Just the plus side, just the negative 3 plus square root of 3 divided by 2, is a negative 0.633974592. That's a weird number. That would not cross at a pretty point on the graph. This is as accurate as we can get. It's as accurate as we need to be. This is using the quadratic formula. We'll do this together in class. On the next time I see you, we'll do B in class together. Let's turn the page. It says solve the equation using the quadratic formula and another method. So hopefully this one's prettier and it's cleaner for us to use. But let's once again write down the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So let's use that now. Here's a, here's b, and here's c. A is 6, b is 1, and c is going to be negative 15. The sign before the number stays with the number. C is negative here. So if I plug this into my quadratic formula, I'm going to do the quadratic formula first. It's negative b, so negative 1 plus or minus the square root of b squared, 1 squared, that's nice, minus, and this is where you have to be careful. I always put this part in parentheses because of the signs changing around here. 4 times 6 times a negative 15. Okay, 4 times 6 times a negative 15. All over 2 times 6. Negative b plus or minus b squared minus square root of b squared minus 4ac times 2a, or all over 2a. So let's start simplifying this. X equals negative 1 plus or minus the square root of, and let's work this square root symbol. 1 squared is 1. Now, 4 times 6 times negative 15 is negative 360, so it's minus a negative 360. Yes, that will end up being plus 360 all over 12. So it's negative 1 plus or minus the square root of 361. Negative 1 minus a negative 360 is 361 all over 12. Okay, so the square root of 361, that is a perfect square. You may use a calculator if you'd like to, or you might have that memorized. That is negative 1 plus or minus 19. The square root of 361 is 19 all over 12. Now this number will break down. We can separate this into two steps. It's negative 1 plus 19 over 12 and negative 1 minus 19 over 12. That's the plus or minus separated. So it's 18 over 12. Because negative 1 plus 19 is 18 over 12, so that gives me 3 halves. And this is negative 1 minus 19, which is negative 20 over 12, which is negative 5/3. So this is what x equals out of this. Those are cleaner. Those don't have the weird square root in it. It's not an irrational number. These are rational. We can write them as fractions. Now, maybe, just maybe, we could do this another way. This is the quadratic formula way. Let's do this using the AC method, or the slide and divide method, because it says do it a second way. If we do that, let me rewrite it. 6x squared plus x minus 15, okay, equals 0. So I'm going to do AC. I'm going to go 6 times a negative 15 and get x squared plus x, and 6 times a negative 15 is a negative 90, minus 90 equals 0. And try to factor this thing. This is just a good review of how to do the AC method. We get x, and this is going to be, we need to multiply to get 90, but be 1 apart. That'll be 10 and 9. That'll get me 90 and be 1 apart, and it'll be positive 10, negative 9. Now I have to come back through and divide by 6, because that's what I multiplied from the start. And we get x plus, that'll be 5 over 3. and this will be x minus 3 over 2 equals 0. So remember to slide the 3 in front, slide the 2 in front. So really our factors are 3x plus 5 and 2x minus 3 equals 0, which will give me x equals negative 5/3 and x equals 3/2. So I get the exact same answer as I did when I did the quadratic formula. That's just showing that it works. It is the correct way to do factoring quadratics. Or you can also see that 3/2 and negative 5/3 we could convert into these factors. 3x plus 5 and 2x minus 3. All right, describe the nature of the solutions for each equation. So that's weird, the nature of the solutions. So this is what it's talking about. The radicand in the quadratic formula is what determines the nature of the roots. Now, the radicand is what is underneath the square root symbol. It's underneath the radical. It's underneath that square root symbol. So in our case, it's b squared minus 4ac. This right here is the radicand. Just what's underneath. Not the square root symbol, but just what's underneath. It is the b squared minus 4ac. That is the radicand. So these 3 points are very important. If you do not do anything else, like other than the problems I'm doing, write those 3 points down. If b squared minus 4ac is positive, if it's bigger than 0, then it has 2 real roots. If b squared minus 4ac equals 0, it has 1 real root. And if it's less than 0, it's going to have 2 non-real roots or imaginary roots, because we'll be taking the square root of a negative number. Therefore, we're going to get an imaginary or a complex number. So let's work this one. And all it's asking is describe the nature and solutions of the root. So all we need b squared minus 4ac. We don't actually have to find the solutions here. So here's a, here's b, and here's c. Plug them into b squared minus 4ac. Okay, so we're going to get 8 squared minus 4 times 16 times 1. That's 64 minus, what's that? 4 times 16 is also 64, I believe. It is, times 1. So 64 minus 64 equals 0. So here, b squared minus 4ac is equal to 0. So we have this step. So it's going to have 1 real root. And that's the answer to this question. Describe it, and that's 1 real root. That's all we have to do. If we wanted to figure out what that root was, we would then go back and use the quadratic formula. We'll do part B in class together. According to the model of Rachel's serve, will the ball reach a height of 3 meters? Okay, so here's the model. Negative 5t squared, I'm using this picture right here, plus 5t plus 2. And it says, I want to know, does it equal 3? Okay, so I'm going to set it equal to 3 and see what t is. If t turns out to be negative, then it'll never reach 3 because we can't go negative in time. But I told you at the very beginning, the quadratic formula has to be equal to 0. So the first thing that I'm going to do is come through and subtract 3 from both sides. So what I'm really going to have is negative 5t squared plus 5t minus 1 equals 0. And now we can use the quadratic formula. I'm going to save this one for class as well. But if you want to, you can plug it into the quadratic formula, the x equals negative b thing, and solve for t. If t is a real number, then you could say yes, it will reach a height of 3 meters. If it is not a real number, meaning if it has I in it, if you take the square root of a negative number, then we will figure it out. We will say that it will never reach 3. Another way to do it, we'll do this and figure out where, if But another way to do it is to just compare b squared minus 4ac. That'll tell me if it's going to be real or not. But I had to do this part first to get the real c. This is c now. Because it wasn't set equal to 0, I don't know what my c is. But here this is going to be 5 squared minus 4 times negative 5 times negative 1. That's 25 minus, that's negative, that's going to be negative 20, positive 20. Okay, well, I don't need to do that. You can type that into your calculator. 4 times negative 5 times negative 1 is positive 20. So this is going to be 5. So yes, it will reach it. Because, let me get that chart back up here. Because it was a b squared minus 4ac was positive, it's going to have 2 real roots. So yes, it will reach 3 meters. Oops, I can't spell either. Okay, yes, it will reach 3 meters because 5 is a real number. All right, so we'll do this one example in class as well. I'm going to let you guys go here. It's a pretty long video. I apologize for that, but this is a very important video. You need to understand the quadratic formula and all its uses. We will study that more throughout the next couple of classes. Other than that, I hope you guys are having a great day. This is Kistner out.